So now we move from thinking about the way in which the human is to what the human now may have to think about as it goes into its next level of development with other kinds of agents that extend our humanity in quite interesting and profound ways. So Aisha Sagan is a associate professor and cognitive scientist and one of the chief researchers in the Arthur C. Clarke Center. So take it away.
Thanks, Sheldon. So that was exactly a great transition from where we came from to where we're going and what I want to talk about. And I entitled my talk, My Robot Friend, but that doesn't necessarily mean that I'm just working on making robots friends. In fact, I'm just, as my colleagues call me, a respectable neuroscientist by day who hangs out and thinks about robots. But why does that happen and how does that happen? And let me try to explain that to you in the few minutes that we have. Which, of course, we just talked about how important for primates social interaction and social cognition is. And understanding other entities, whether they're humans or animals, is extremely important. We do it all the time. But it is one of those things that's been very, very hard to model in artificial systems. At some level, this shouldn't be so hard because our ability to extend intentionality or socialness or aliveness extends towards inanimate objects on a day-to-day basis. We're able to see faces in animate places. These animations that you're seeing over here are just a few little triangles, but by virtue of the way that they seem to move and interact, they evoke a scene in which a lot of normally social things that happen among animate entities are happening. So our brains are able to read in a lot of that into inanimate objects. So I want to talk a little bit about, if I can, where we came from and where we are going. In terms of our brains, the future of the social brain. And I have this hook or the challenge of this robot friend, which I just want to use as like a shortcut to refer to this idea of creating intelligent artificial systems, building artificial systems that are emotionally and cognitively intelligent. Now, I want to leave aside for a moment whether this is a good thing or a bad thing. There's a lot of discussion that we need to actually have about why we would be building artificial agents, why we would want to have robot friends, why don't we have real friends. We need to think about those things. But we, as scientists and as UCSD, really need to engage with this issue seriously. For one thing, there are applications of these technology in education, healthcare, entertainment. Every day there's a discussion about a new robot or a virtual reality system for treatments of different disorders, for children. We just really are already in it. It's already happening, so we as scientists really need to engage with it and try to understand it. The future is going to involve not only other social entities that are artificial, such as robots and avatars, but also ourselves acting through such entities, such as avatars, or augmenting our bodies, changing our bodies with the use of prosthetics and augmented sensory systems. Now, the vision that we have when we think about an artificial agent, and many of you are probably more mature than I am, so you probably don't know what that is. It's cartoon South Park, where one of the characters has a robot friend named Osimo. Of course, Osimo is actually one of the other kids dressed up in a cardboard robot suit. And I'm really sparing you the song here because it's going to get stuck in your head and you'll never be able to think about it. But the song says, you know, hey there, have you heard about my robot friend? He's metal and small and doesn't judge me at all. So we really want robot friends that we can communicate with, engage with, and possibly they could even be better than real people, right? We don't have to work so hard for them to accept us. Let's say that's the vision. What do we have today? We have a lot of actually technology that has gone towards creating artificial humans. We have humanoid robots such as the one in this video, which is from a lab that's one of our main collaborators, that really look like people. In fact, she's modeled after a real human, which you will see in just a second. If you just look at how the appearance is, we have come a long way at being able to create robots that look like us. However, the behavior, and even this is a video that's showcasing sort of the best of, leaves a lot to be desired in terms of the naturalness of the movement, the naturalness of the interaction, and so on. Another thing we have, examples of technology that's available today. This is the deceased rapper Tupac Shakur performing at Coachella in 2012. Again, this technology and the body movement and the rendering of this hologram Tupac, it's really impressive at some level. But this is a very limited environment where, you know, somebody is performing. And today, we can't just sort of have a chat with Tupac and, you know, go have a coffee with him. And perhaps we wouldn't want to. Again, another celebrity that's sort of been reanimated, Audrey Hepburn. This is I believe, a chocolate ad. Again, it's pretty realistic in some ways, but if you keep watching, it's just not the real Audrey. So what we have, a lot of impressive, evocative, already existing artificial humanoid systems, but they're not quite right. So why is it so hard, though? Like, we've been making things in our image for a really long time. We've been making dolls, we've been making statues, we've been making early robotic systems. Why don't scientists get on with it and make the robot friend already? Well, the sensors got better, computation got faster, graphics, materials, there have been a lot of advances, data science, the ability to sift through science very fast. These are all big achievements, but they're not enough. And the main point that we come to is that when you decide whether an agent is real, alive, intelligent, conscious, a friend, what have you, you are the one making the decision. The human is consciously and unconsciously making these judgments. And in order to be able to, therefore, model these things, we really have to go back and understand how the human brain is doing those things. And that's sort of what Ralph was talking about earlier. So one idea could be, why don't we just imitate humans? One thing that happens, and some of you may experience this when I showed the videos earlier, is this uncanny valley hypothesis. So instead of making an avatar or a robot more and more human-like, increasing the response to the human just linearly makes it by default more positive. The idea is that there's sort of a nonlinear relationship where, yes, a human-like appearance is good to some level, but after you get to a point where you become really close to a human, you start getting to actually evoke a negative reaction from people. Now, this is just sort of a hook that I want to leave you with in terms of the sorts of stuff that we need to explore and some solutions that may come. In our research, we've been trying to understand human brain responses and to try to use data from neuroscience to inform these questions and how the human brain responses can eventually be used to evaluate new artificial agent systems. And this is difficult to do with fMRI, which is the data that I'm showing here, but with machine learning, big data, neuroimaging, and brain-machine interfaces, all these buzzwords that we at UCSD are really quite good at, are coming to a point where we could really put these things together as an opportunity to create intelligent agents that can sense and adapt and react to us. So we not only have these robots and avatars that are designed really well on the outside appearance, but they sense our responses to them, and they intelligently adapt to our responses to them. So I feel like that's somewhere that we at UCSD should go and fill this gap.
Yep, go ahead.
I'm not mistaken, you flashed by a slide with Alan Turing on it. So when will a computer pass the Turing test?
Essentially, if you start getting really close to a human and start behaving like a total Turing test, let's say, face-to-face Turing test, to really pass for a human is very, very hard because we're working against millions of years of evolution that has sort of made us really attuned to how humans behave. But if you start making a robot that looks like a robot and not necessarily so close to a person, people are much easier to ascribe intentionality or agency to those things. So I think the Turing test is actually going to be very, very hard to pass for some time to come, but we're still going to be able to sort of make headway towards creating social systems that are adaptive. Sorry if it wasn't clear. Turing test is essentially a computer passing for a human, becoming indistinguishable from a human.
Hi, I have a question. I'm not a neuroscientist, but I spend a lot of time with human beings. Humans like to control things. You're very focused on making something look human-like, but human interaction with machines is mostly about how well they can control it. So can you tell me something about that?
So if I understand correctly, one of the main goals of artificial intelligence is to create machine systems that do certain tasks. Another goal of AI, which was sometimes called a strong AI, is actually model how humans do those things. And as you know, humans, it's very difficult to control other humans. So if we sort of get close to actually modeling a real human, we might actually end up with that big fear as a society that we have of, robots taking over the world, Frankenstein and hell and so on. So I think that we're going to make headway towards making systems that we can control in specified domains, such as, helping navigate a car, even though that seems difficult. But a general purpose human model remains very difficult to make, and when we make it, it might be impossible to control.
Our humanity in quite interesting and profound ways. So Aisha Sagan is a associate professor and cognitive scientist and one of the chief researchers in the Arthur C. Clarke Center. So take it away.
Thanks, Sheldon. So that was exactly a great transition from where we came from to where we're going, and what
So now we move from thinking about the way in which the human is to what the human now may have to think about as it goes into its next level of development with other kinds of agents that extend.
But it is one of those things that's been very, very hard to model in artificial systems. At some level, this shouldn't be so hard because our ability to extend intentionality or socialness or aliveness extends towards inanimate objects on a daily happen. And let me try to explain that to you in the few minutes that we have, which, of course, we just talked about how important for primates social interaction and social cognition is, and understanding other entities, whether they're humans or animals, is extremely important. We do it all the time. I want to talk about. And I entitled my talk, My Robot Friend, but that doesn't necessarily mean that I'm just working on making robots friends. In fact, I'm just, as my colleagues call me, a respectable neuroscientist by day who hangs out and thinks about robots. But why does that happen, and how does that